Hey everyone, this is Mr. K, and today we're going to go over what is an integral as well as integral notation. So we'll start with integral notation. That is the symbol for an integral. It kind of looks like an S. I know mine's not super perfect, but yours won't be either. So you all have values here. Sometimes it'll be x's, sometimes it'll be numbers. We'll start with numbers, but for now, just for this example of a and b. And then you'd have some sort of equation here. I'll call that f of x. It'll be like x squared plus 2x plus whatever. And then it will always end with d something. In this case, I'll use dx. And so what all these things mean, this little s here is like the integral symbol. The a is considered your lower limit, and the b is considered your upper limit. So it's like so when you take an integral, unless it's an indefinite integral, which is going to happen later, you're always bound, like you're looking at a certain section of the equation. You're not looking at the entire graph, just from a to b, whatever those values happen to be. So it's your lower limit, upper limit. F of x is actually has a vocabulary word, special name. It's called the integrand. And that's the equation you're actually like integrating. And then dx, it's called your variable of integration. And really what that means is like when we did derivatives and you talk about like taking the derivative with respect to x or with respect to y or with respect to t, it's the same thing just with integrals because we're doing like derivatives backwards. That's why we need like it's kind of like you're integrating with respect to x in this instance. So you'll always see a dx, dy, d something, du. You'll see that later on. So those are like the different parts of an integral. What an integral actually is. So if I draw a graph here, let's say I'm going to graph y equals x plus 1. The graph would look like this. I'd start at 1, I go up 1 over 1, and I'd have an equation of a line, again doing something like that. So an integral is actually finding the area underneath the curve. So for example, if I really wanted to find the integral of, we'll go from 0 to 2 of x plus 1 dx, what I'm essentially looking for is I'm looking for the area of that shaded region. And so what you could do is you could go through and calculate, okay, I'm going to split this up into a rectangle. The height of the rectangle is 1. The width of the rectangle is 2. So I know the area is length times width, so I know the area of that rectangle is going to be 2. Plus now I want to add the area of the triangle. For when I look at the triangle, the base is 2. The height is 2. So then if I do base times height divided by 2, it would be 2 times 2 divided by 2. And so I'd have 2. There's a lot of 2's. And so this integral would equal 4. And that's how you can calculate integrals for now. It could get a little more complicated. Like let's say I had, for example, I wanted the integral from -2 to 2 of, we'll use the square root of 4 minus x squared dx. The graph would be a semicircle going from -2 to 2. And so what I would do is, if I want to find the area of this shaded region, I would do half pi r squared, because my radius of my circle would be from the center out here, which is 2. and then I'm only taking half of the circle, because normally the equation for area of a circle is pi r squared. We want to cut that in half. And so this would end up being 1/2 pi times 2 squared. And so you'd end up with 2 pi as the area of that shaded region. One other thing to note, and it'll probably come up more so later, is whenever you have a curve that goes underneath the x-axis, so for example, if I wanted the integral from negative pi to pi of sine x dx, the thing to be careful of is that when it goes below the x-axis, calculating that out counts as negative area. I know that's not a normal thing that you think about, but it happens when we're calculating our integrals. And so if I want to calculate that integral, the curve here would look something like this. And so here would be pi, here would be negative pi. And now something that I know is that this area right here is going to be positive, this area is going to be negative. One nice thing about sine and cosine waves is that they're symmetric. So what that means is that I don't know, I could go through and calculate the area, but I don't know what this area is, but I know that it has to be equal to this one. And so because one of them's positive and one of them's negative, they're essentially going to like cancel each other out. And so this integral will equal 0. So that's just a brief explanation of what an integral is, how do we write it out using notation, and then a couple of examples of how to actually calculate integrals. I hope you found this helpful. Have a fantastic day, and we'll see you in the next one.